So I think I would like to start with a small intro, if you can do, what you're working on as well.
Yeah, I can start. Hey guys, my name is Bo. I'm a co-founder at Polymer, where we're working on extending the IBC protocol to all chains.
I'm Fig. I'm co-founder of Squid, and we're doing cross-chain swaps and transactions across the Cosmos and EVM, and soon to be many more.
I'm Richard. I'm a co-founder of Orb Labs, and we're building a chain abstraction stack.
I'm Jim, co-founder of Catalyst. We're building sovereign liquidity for the modular future.
Thank you very much. I think we often hear a lot of different words when we talk about bridging. So I think we hear transport layer, cross-chain messaging protocol, cross-chain router, token bridge. Could you sort of explain, maybe take one each, and explain what that specific topic is, that specific thing is?
I'd love to talk about the transport layer. I feel like it's something that's not really considered in interop. I feel a lot of people talk about the state layer. They talk about security. They talk about how do you verify something that happened on one chain on another chain. The transport layer deals with encoding of the network topology of the entire network on chain. All the paths between chains, all the paths between all the smart contracts that want to talk to each other. This information needs to be encoded on chain. IBC does it. Very few, or basically no other interop protocol does that.
I can talk about routing, and that's what Squid does. Essentially, routing is when you look at cross-chain just from the lens of connecting applications between chains. So we take the view that there's liquidity all over crypto that just needs to be connected, and we use general message passing and different infrastructure layers we use Axlar to access that liquidity. And so a user should be able to interact with any application on any chain in just a single click. And it's a little bit like Google Maps, but if you could teleport. So we always find you the way to what you want to do, but it should happen as soon as possible.
Yeah, and I think with messaging, cross-chain messaging at least, the focus is more so passing data from one chain to another. And Bo is right. The reason why most messaging protocols don't focus on the connections is because it's possible to have connection-less interoperability, where you don't need to know the direct paths beforehand and still pass message from chain to chain. And so you find that for most messaging protocols, establishing those connections at least beforehand is not a main focus.
And I guess I can take token bridges, if I think that was something you said, right?
Yeah.
As an option. So token bridges, I think, is a pretty archaic term, at least how I define it, where, I think several years ago there was a need to move coins between their kind of home blockchain to a new one. And so bridges were kind of made as a primitive in order to enable that. And so bridges for me are some function of wrapping a token or minting a new token on these kind of new destination chains in order to get access to this token. And it's backed one-to-one to kind of this vault of the original tokens that are stored on the home chain. And so literally a bridge, right? It's like you're just kind of shooting an asset from its home to another location.
Thank you. I think what you all sort of touched upon a bit was standardization to some extent. So we already have a lot of different token standards. How do you bridge one token standard to the other? And also in messaging. So how do you view sort of standardization, and how do you think we should sort of go towards that?
My long-term view on standardization is that at some point, chain developers, if you relate them to operating system developers, are going to want to enshrine something into the blockchain kernel itself. What that is will probably be an open standard, be net neutral, be decentralized. I mean, I slightly disagree with Richard here on the need for encoding these connections on chain, because I think that if you don't encode this information on chain, you cannot prove anything about the network. In fact, you cannot prove that you have a smart contract that is bound to another smart contract across any number of chains. So I think that when these chain developers do come to make this decision, IBC is the best candidate here.
I think you're going to realize Bo and I are going to be going back and forth. We tend to have very different views on interoperability. But I think going back to standardization, I'm very pessimistic as to whether it will have all the developers aggregate underneath one standard, simply because it's in their best interest not to. If you think about a world where there's a even 10% chance that there's a different interop standard that sort of like makes interoperability slightly better for some other chain that didn't choose to enshrine a particular bridge, you're probably going to want the option for that sort of standard to come to your chain. And so what we're probably going to see instead is we're going to see some sort of wrapper protocol that comes and bundles up all these interop solutions and gives applications on top of these chains the ability to move seamlessly from chain to chain. But yeah, going back to the options between connection-based or connection-less interoperability, I'm pretty sure it's still possible to make it very easy to pass messages without sort of like storing and encoding all that data on the chains that you're going to, partly because most of that data is also already encoded in the security layer, or the state layer, which what would call them. So yeah, that's the general thought there.
Any more thoughts on standardization, or?
I think what we're seeing right now is there's some projects that are just brute forcing it, right? I think we can all agree in this panel that there is like pretty kind of there's a pretty high degree of heterogeneity in the ecosystem as it pertains to varying standards or varying protocols that not only span general message passing, but also, as we were alluding before, kind of the token level as well. And so there are projects like Socket and Livefire that are just saying, hey, like, we'll just kind of put the man hours to aggregate all those things and then abstract it in some sort of off-chain way, right? What I have been seeing is, while that works, and I'm sure will continue to work, there has been kind of a deliberate effort to make their jobs a little bit easier. And so, there's this new ERC, I'm blanking on the name, that Arjun from Connects kind of offered that is kind of championing that, right? And so it's good to see a lot of the liquidity networks like Connects and our team at Catalyst included, seeing that there needs to be some sort of standardization in how we wrap tokens when we bring it to different chains. And so we allow for not only more interoperability, but also kind of more shared agreement on the security assumptions of that wrapping.
Yes, you sort of touched upon it a bit in the end here. Sort of, if I'm a dev and I'm building an application, I need to choose a question messaging protocol or a bridge or whatever it might be. What kind of trust and security assumptions should I be looking at, and what do I need to consider?
I can go. Just in the standards piece as well, I think it depends where we are in the innovation cycle, because I agree that there's going to be experimentation. If there's a chance that something's going to work, someone's going to go for it and build the product. But potentially with bridging, for example, it's quite an old technology now, and we can start to standardize it. And people are, like the Connects guy, looking at ways of like abstracting it in a way so that you can standardize it for everyone. But our job at Squid is a little bit like the aggregators, where we integrate protocols across different virtual machines, like different chains, different gas models, and we have to deal with all of that complexity. I don't know if we're anywhere close to getting standards in a lot of these places, but so there's just going to be a ton of work on our end, I think, to just deal with that for now. I think we could end up as like a temporary standard, and then hopefully the ecosystem like finds its own way to become very similar across the board. But for now, we need to make things usable, and evolution will play its course.
So will the best standard win, or are there other reasons why a standard might win?
I don't think so. I mean, Solidity is the standard now. So, and I don't think many people agree that it's like the best, and JavaScript's maybe the standard. It's gonna play into a lot of different factors, probably non-technical ones.
Okay, perfect. We had a sort of modular ecosystem day, and we obviously Celestia is a DA layer. How do you guys think that sharing a DA layer might help in bridging between rollups or chains or whatever else it might be?
Sharing a DA layer allows you to have trust minimize interoperability between those rollups. If you share the same DA layer, let's say they're optimistic rollups, you have the security of that DA layer saying that I can make this data available to anyone to be able to generate a fraud proof. That means that this economic security of the DA is shared among the rollups on top.
Yeah, and I think even going back to the general idea behind rollups. So rollups, in many cases, at least for L2 rollups in Ethereum, get the states for all things happening on Ethereum sent up to them. And so in the case where you share its DA layer, you can sort of like run light clients that sort of like look at the state coming from the DA layer and even compute a full node that computes the state of all the blocks that are basically being broadcasted down to the DA layer. And through that, you can extract the message you need. So how that differs from light clients that sort of like rely on, well, separate DA layers is you run into the problem where it's possible for the DA layer to fork, and you may have sent over a state from some other chain showing a fork that ultimately was deemed invalid. So I guess comparing shared DAs with light clients to not shared DAs with light clients, what you have is just a slightly more robust system for passing messages from chain to chain.
Perfect. Any more thoughts on that?
Yeah, I'm not going to talk about the security properties of it. I do think the benefit of sharing DA, and depending on how you use the underlying DA layer, you might also use it for canonical transaction ordering. You do allow for soft confirmations of the state verification of the messages being passed within the execution level. And so with that, you have quicker finality, right? Because you're essentially saying that because this data is made available, because either there's a canonical ordering of the transactions using the transaction ordering layer of this DA layer, or even if you're not doing that, you still have the data made available so that you can have fraud proofs, or so that you can reconstruct some of these validity proofs. You are basically allowing for soft confirmations at the cadence in which blocks are produced at the DA level. And so for Celestia, like several seconds, right? And so that is a sufficient user experience, even if there's latency introduced at the execution level for true finality.
Okay, perfect. Maybe more of a question for Fig and Jim here as well. I think you've talked a little bit about the UX problems that we run into with bridging. And how do you foresee how do we fix this? Can AA help? Can intent help? Like what kind of future do you foresee in terms of UX?
I mean, the data availability is, what everyone was just talking about is a good example of UX, where we just found out that, I didn't know this, that the optimism token is minted on the optimism rollup and not on L1. And so there's a bridging problem, like how do you bridge OP without it being like fragmented now, because they could have just minted it on Ethereum and then suddenly you have all these canonical versions via the enshrined bridges, but it's going to be a mess. And I think you're going to need these, that's what we do, we have these abstraction layers where you can just get whatever token you need for an application, and even if the application is supporting the wrong token, but technically you can get that token, use the app in one click. And intents are this idea that you just have something that you want to do and you send it off into the world and someone magically solves it. And I think what we're doing is sort of like a proto-intent system where we're the only solver, but and we have a feature called Boost, which we're really excited about. We just launched in the last week, which allows you to essentially declare your intent on the source chain, and then that will get finalized over 20 minutes or however long the bridge takes, and anyone can fulfill that transaction on the destination chain immediately. And it's fully generalizable because it's using general message passing. It can be a swap. You can buy an NFT across chain. You can do staking across chain. And that's the user experience we want. We want people to do anything in any application in one click as soon as possible. And yeah, I feel like we've gotten there. We've started just with something which works, and then you can decentralize that more over time. And I think, yeah, really excited for intents and to integrate them into Squid as well.
Yeah, I don't have too much to add as it pertains to intents. I do agree that routing systems like Squid and the ability to have kind of a sophisticated entity provide the liquidity for fast liquidity / soft confirmations of those transactions is really awesome, right? I think that augments the UX considerably. I do think we still, even in that paradigm, well, two things I'll add. One is that I think intents are really interesting, but I don't think people talk about solvers enough. So what Fig at the Squig team and doing kind of the boosted feature, what they're doing there is really kind of starting the conversation of how do we have infrastructure that is not articulating intents, but actually fulfilling or providing the liquidity or providing the tools for these entities to fulfill those intents. So I think we need more kind of advancement and more investment focus into that piece. And I think where we come into the picture is kind of the second piece where even in that paradigm in which we have really robust infrastructure for solvers to fulfill these intents, we still kind of face what I think is a cold start problem when you look at new chains. And so I think it's pretty kind of consensus now that there's going to be lots of rollups, right? Hundreds of thousands, if not millions. Within that kind of framework, like if you have a brand new chain, it's a really difficult problem. It's a really difficult problem to try to inject liquidity into a brand new chain that's basically a barren wasteland. And so how do you solve an intent for a new chain when there's no liquidity, right? And so that's a big research question that we think a lot about Catalyst. And so we're hoping to slot into kind of this refocus into the solver problem space.
I do think most of the conversation around intents currently focus a lot on a very defined problem, which is swapping one asset for another. But there's a big question on if intents are going to eventually become, let's say, the end game of interoperability, then we're going to need to find ways to generalize intents to almost every possible transaction. And I think that problem's extremely difficult and maybe the main bottleneck to us ever getting to this final state of interoperability, partly because intents in many ways are invariant programming. You basically have to, well, configure your system to check against maybe an infinite number of invariants to make sure you don't break things. And yeah, that's not an easy problem. So I think we're going to see a lot of maybe proto-intent systems that combine transactions and intents for quite a bit. And then eventually, perhaps after several years of thinking about the problem more, we might get to a generalizable intent system.
Anything on that, Bo?
Yeah, since we're talking about intents, I'm kind of on a tangent now, but would love to kind of talk a little bit about the work that Anoma is doing and how it can apply generally at the interoperability level. So if you think about the research that they've done to, say, allow chains to combine or take the union or the intersection of the validator set between multiple chains, bootstrap a temporary chain, they call it chimera chains, and be able to create cross-chain atomic transactions. If you were able to standardize at the networking level, so at the interoperability level, let's say IBC everywhere, hypothetically speaking, and IBC were to have access to the consensus mechanism of all these different chains, you could apply the ideas of heterogeneous Paxos and do essentially cross-chain atomic IBC transactions across all IBC-enabled chains. I think we'll see some of this, but I think it'll take like probably quite some time to get to this end state.
All right, perfect. So some of you have talked about a world of hundreds, if not thousands of different chains. Do you think we end up in a world where there's like one aggregator aggregating all kinds of different cross-chain messaging protocols, token bridges, whatever else it might be? So how do you foresee sort of aggregation working out?
Well, yeah, definitely be Squid. There'll only be one. And everyone will use the Squid SDK to build their apps, and there'll be some Squid widgets, which everyone uses in all applications everywhere. All the wallets will have us installed. So I think, yeah, I mean, it's going to be like, there'll be a few winners, I think, in all cases. Like, there might be a few interop winners, there'll be a few aggregators. It depends what you end up focusing on as well. Like, we try to not take the approach of we're aggregating everything, we're just doing swaps, and then you can pair a swap with something. So it's more like a payments layer. Maybe you have NFT aggregators, and as we find more actual use cases for crypto, then there'll be more solutions that might be the winners. But
Yeah, I mean, I think aggregation theory that a lot of people talk about, either on their Mirror blog posts or you can look at like Strategery, is probably going to play out where you see kind of like a power law distribution where there's going to be a handful of short tail suppliers for aggregation. And they might say they're differentiated, but the reality is like from a user behavior perspective, you just end up using the three of them. It's like when I get a hotel or like when I want to live, like stay somewhere, let's say for ETHCC, I just end up checking like 5 platforms now. They're not differentiated anyway. I just have to use 5 of them to get access to everything. And that's fine. I mean, I think that's just how the economics plays out.
I do have a bit of a controversial take, though. I do think the intent future, or at least the intent future envisioning, is directly counter to this aggregation future, partly because once you introduce solvers to the mix, solvers are way more sophisticated than your end user, and they will more than likely explore a wide variety of possible different places to get the assets they need to basically optimize or maximize their profits. And so we could see a world where aggregation doesn't really take place, but we have a number of liquidity networks and token bridges that people just generally go through from one to one just to make sure they get the best possible profits. And these layers will be fighting based off of, well, who has the lowest slippage, who has the cheapest gas fees, who has like the fastest times, and so on.
Right. Do you have anything to add, Bo? Or?
Yes. Once again, I'm going to talk about the lower layers of the stack while everyone else talks about the upper layers. I would say that I think at the lower layers of the stack, we're going to see some consolidation, probably in the 10 to 20 year time frame. I know people don't really talk about 10 to 20 years in the crypto space, but it's about how long it took for the world to kind of converge on a roughly this, a consistent networking standard, TCP/IP. In fact, in the early 70s, 80s, there were a number of proprietary, I would say like company-owned protocols that were kind of seen as these de facto standards of the time, maybe like a layer 0, for example. And over time, they congregated, because if you're, Apple, and you've implemented Apple Talk, Microsoft might not want to implement Apple Talk, but Microsoft will be a little bit more open to implementing TCP/IP per se. So I think like the world will converge to IBC in the long-term time horizon, but in the short term, we'll see a lot of aggregation at all layers.
All right, perfect. So maybe to move the thoughts towards, I think a big difference in some of you and other bridging providers as well is the fact some might be using a state or a middle chain to verify messages. Some don't, layer 0, for example, and others as well. What is your opinions on having a state middle chain? Do you think the sort of crypto economic security it provides is good or bad? Some might, say that. Or what are your opinions on that?
So I think the idea of a stake middle chain comes with some baggage. I think it comes with the baggage of generally these protocols implement some proprietary, cross-chain gateway protocol, nothing wrong with that, but some other protocol that the chain or the team that owns the chain controls. I think having middle hops in network topology makes a lot of sense. I think if you want to scale network topology and you have a lot of heterogeneous infrastructure, you do need middle hops. That being said, I think long-term, you still want to converge to a single standard, have middle hops in between. Obviously, you want these to be secure as well. Ideally, you want them to be trust minimized. If you can prove the execution of an entire path for a particular packet, then you can remove trust on these middle hops in the long-term time horizon. So I think that the stake matters a lot now, but I think as technology advances, I don't think it will matter as much for security.
I think right now they're ticking time bombs, partly because if you think about it, the whole idea is that economics will always make it, not profitable for a malicious party to basically exploit those chains. But as more and more chains connect to various chains as hubs, take like Axel or Polymer, which are trying to become hubs for IBC, it may just end up being the case there's way too much value built on it that like even the validators don't have enough economic incentives to keep the network as robust as possible. And the only way that changes is a world where the light clients they're using for passing messages from chain to chain are no longer necessarily just checking their validators to see if they provided the right signatures, and more so running complete state transition proofs of all the transactions happening on those chains. And at the point at which you get to that particular level, they don't no longer need to be validated chains. They can just become rollups and do the exact same thing. So yeah, I think we're probably going to see a world where all the validator-based networks effectively start to do the exact same thing rollups do in order to become robust or very secure, or they're just going to implode because the economic security no longer holds.
And I'm assuming you have some thoughts on this as well, Fig.
Yeah, sure. Yeah. No, I agree with what you guys are saying for sure. It's a temporary solution that will upgrade into a more trustless solution when the technology gets there. But for now, we need a solution that we can connect the like unusual chains into like other networks which are maybe more interoperable with each other, like IBC. And then IBC is developing, and like over time it will get more capable. But for now, we want to connect Ethereum to the Cosmos, for example, so that the Cosmos can get some users and build up business relationships. I think the economic security, honestly, that's a ticking time bomb. But with the number of users at the moment, it's more about. I think there are so many other things to be worried about with security in bridges. It's the Nomad hack, for example, was just at the smart contract layer. In fact, I think the Solana hack was it Solana? No, the wormhole hack was similar, $300 million, and it wasn't anything to do with economic security. But definitely, centralization is going to be the cause of a lot of hacks. And Axelar having 75 validators compared to, say, I won't name names, but in the 5 or 6 range in a lot of cases, it's completely different, and so much harder to hack. And then these chains become like Polymer and Axelar take on a different role in a future where everything is trustless. They can be routing hubs. They can potentially have a programming environment where you can build network logic for specific applications, like gas networks, for example, or they're a way that you can program into the networking layer. And yeah, that's it.
Yeah. One tiny rebuttal on the point of, well, the number of validators being the main thing that sort of like keeps things alive. I do think it's a combination of the validators and their stakes. And when you compare most of the chains that do have these diverse sort of like validators, you still find that the stakes aggregate into some sort of like few hands. Just because, well, for the most part, you probably find that it's probably the team that's running most of the validators on chains like, Axelar. I do think the bigger point, though, that stands is for us to get to a world where we sort of are comfortable with these hubs, they're eventually going to have to change or switch to some variant of a light client system that depends almost entirely on state transition proofs as opposed to, well, the validators. That way, we sort of like move the security away from the validators and their stakes to, well, math and whether we're running the right computations.
Are you in agreement, Jim, as well?
Kind of. I do think proof of stake or leveraging economic security is not as big of a ticking time bomb as my fellow panelists may think. It's a coordination problem, right? Like, let's say you move more economic activity than your underlying stake, which, surprise, Ethereum does, right? It's like, that's where decentralization matters. It's like, okay, like, let's say you're using vanilla Tendermint, or I guess Comet BFT, they call it now. It's still a coordination problem for all these validators to collude and actually, have a erroneous state transition occur. But I do agree that we're probably going to move away from that model, not because it's a ticking time bomb, but because it's just inefficient, right? Having a committee of validators run full nodes of God knows how many chains, right? I would say you could probably, depending how beefy your nodes are, run 200 chains, like, which is higher than I think most people would probably say. But anything more than that, then it's not going to happen.
Yeah, so what you're saying is that each of the validators would have to run a full node for all the other chains they support?
Yeah, precisely.
And I guess also incentivizing sort of the validators as well could also be a problem too. We've heard a lot about CK bridging, I think, over the last couple of months and years. Do you guys have any thoughts on using CKPs in bridging, making either for trust minimization or for batching block headers or transactions into CKPs?
I'll start mainly because I'm the least qualified, so I'll give the most high-level opinion about it. I think they're important. I think there's still a lot of open questions on what that looks like when you have, heterogeneous proving schemes, when you have latency on, posting proofs on chain and verifying them. But like what Richard was saying, like, that is the end state, right? It's like, we can't be verifying the consensus, or said differently, we can't be snarking just the signatures of these validators of underlying execution layers, but we need to be actually verifying or proving the computation of the actual state transition occurring, right? I think the solution to this kind of the open questions that I'm talking about is two pieces. One is there still needs to be a hub, right? It's like heterogeneity of all these proving schemes, all these different rollups. You probably want a prover aggregator or proof aggregator, or like using some sort of recursive proof system in order to make sure that they become homogeneous, right? And you probably still need a router, honestly. Like you can't have millions of chains all talking to each other in pairwise kind of permutations, right? And then, like what Bo was mentioning, snarking the actual path of that packet becomes really important. And then on the cost piece, I do think optimistic ZK, right? Like I had a tweet I was saying like, I think everyone's talking about how off-chain is the future, which is kind of ironic. But optimistic ZK is interesting, which is where you snark something, you don't verify it on-chain, but you could verify it on-chain and becomes like a one of n, like fraud prover kind of setup.
I feel like you probably have more to say.
Oh, I have a quick one. I don't have too much to say on ZK bridges other than excited for when they come live and we'll use them. But I wanted to correct, Axelar's team doesn't run any of the validators, and it's a permissionless network that anyone can join and run a validator. That's the big difference between it and, say, multi-chain, which just got hacked a couple weeks ago. Which literally, it was an MPC protocol where the CEO owned all the instances running all the MPC nodes, which was insane. But yeah.
Yeah, the state middle chain approach is definitely more secure than multi-sig.
Agreed, yes. On the topic of ZK clients, I would say that there's obvious performance issues that you want to work through, and that will improve over time. On the front of proving the entire execution path is something I wanted to drill into. So one advantage of encoding some of this network topology on chain is that now you have a subset of the keys that are owned by each and every particular path. So you can shard proving of the execution of one particular path and separate that away from proving the path for communication between another set of smart contracts. And you can do this on a smart contract to smart contract basis. If you don't have this information on chain, it's very difficult to scale proving.
Anything to add on that, Richard, as well?
I don't know if I completely buy that, but I think I have to think about it more. But I think, yes, light clients will be the final state of interoperability. And I think coming to this event, I realized that a lot more people think that it's further out than it actually is. I think most of the tools needed to build extensible light clients currently exist. It's just a matter of, assembling things like Lego blocks. And once we do that, we should be able to have light clients for most of the, popular networks and frameworks we currently use.
So if we're in a future where all chains support light clients, do we just not use smart contracts at all and just light clients for bridging?
No, we will still use perhaps some optimistic system, partly because of the latency that comes from proving these chains. I think perhaps the end state of bridging would be optimistic with light clients for dispute resolution, if anything. So imagine a world where someone, states that something happens on some chain and some people just monitor this particular proof. And if no one disputes it, then, hey, we're fine. And if someone disputes it, we check the light clients to make sure that they're not lying. It makes more sense given that, until the hardware becomes really good and the proving software becomes really good, we're still going to be looking at perhaps 3, 4, 5 minutes, sometimes even up to 12 minutes worth of latency for passing messages from chain to chain. And people aren't that patient. So, yeah.
I'm going to take a quick second to shill the work that we're doing at Polymer. So we're working on, since we're on the topic of optimistic ZK approach to interoperability and forming that connection, we're working on optimistic ZK IBC connections at Polymer. So we have working ZK IBC connections, and we're working on overlaying optimistic verification on top. And we expect to have that and hopefully testing in a few months. So, yeah.
Cool. So we've talked a lot about how we can solve interoperability. So in a dream world, maybe 5, 10 years from now, what kind of applications are you looking forward to seeing? Like what kind of cool applications can you build when you have 1,000 seamlessly connected chains with relatively decent latency?
I think a lot about the idea of borderless finance, where everything that we own becomes kind of aggregated within one single interface, irrespective of where it lives. And this goes beyond an on-chain context, right? And so my shares of certain companies that aren't doing too well right now, or my cash assets or my real estate, it's all in the same view as my crypto assets. And there is ample liquidity in moving between all of those in whatever action I want to prefer. And so interoperability obviously is on chain right now, but I do think that there is a lot of research underway of how we kind of, whether through the use of ZK snarks or what have you, bring real world assets into it as well. And it becomes a lot more delightful, I think, to own financial assets in the meat space.
Very cool. What about you, Richard?
I think when all is said and done, the main product that we'll see enabled by interoperability will be some variant of a cross-domain intent protocol. I think the end state of interoperability will be the chains themselves sort of disappear. They only become a thing that the developers care about. Very similar to Web2 in many ways, right? Only you care about where you deploy your application. Only you care about where your software sits. Users just care about them being serviced. And yeah, until we have that, we're probably not going to cross over that, million or billion mark that everyone keeps on talking about when it comes to users.
Yeah, I agree with that. We just need a way for people to build projects and be able to add. I mean, at the moment, I feel like the only use case we have is payments, but you can imagine also making the Web 2 example. I'm really excited about how you can potentially bring AI into the intent system. Like we've actually built a proof of concept in Squid, and we're working with Dora, who are in the audience on it, and they've built a thing where you can they're like a search engine, like the Google of crypto, where you just type in what you want to do, and then it goes through the Squid SDK, and it finds, say you just want to mint an NFT, it finds the NFT somewhere, builds the transaction packet so you can buy it from anywhere, and you've got your NFT. So you can potentially imagine a world where you have a Google, like just a search bar, which is your entrance into getting anything, or at least finding an application, and then interoperability allows you to access that in one click from anywhere.
I love what everyone said. Borderless finance is very important. Some of the early applications in crypto are financial and have priced out some other applications. Me personally, am very excited about gaming. I'm a huge nerd and I love computer games. So I recently saw a post. Someone had tweeted about having on-chain like a variant of Warcraft. If people are familiar with like real-time strategy games like Warcraft, StarCraft, these are kind of like your, Age of Empires as well. There's a number of them. These tend to be your like classic real-time strategy games. But having these on-chain games and be able to prove it is a very interesting use case to myself personally. I would love to play these games. I would love to be incentivized to play these games as well.
All right, very cool. I think we're running slightly beyond schedule, so I don't think this is correct. And I know there's a happy hour outside. So thank you very much for joining our great panelists today as well.
Thank you.